Hello friends, welcome to my channel Civiltastic. We are here to learn about rocks and stones. Let's begin with rocks. What is a rock? Rock is an aggregate of mineral. They have a definite chemical composition but do not have a definite shape and size. If the rock contains only one mineral, they are called as monomineralic rock, and if it contains several types of mineral, then they are called as polymineralic rock. An example of monomineralic rock is dunite. An example of polymineralic rock is granite. Rocks occur naturally in the earth crust. They form the upper layer of the earth crust. Stones. Stones are derived from rocks. Stones are one of the major building material used in the construction. Stone has good strength and durability. Stones were used in the history to build the forts and monuments. The Taj Mahal and Red Fort are made by the use of stones. Khajuraho Temple, Sanchi Stoop, Parliament and Presidential House are example of stone architecture. Now let's study about classification of rocks. Rocks are generally classified into three types. They have physical classification, chemical classification and geological classification. Let's deal with the geological classification of rocks. Geologically, rocks are defined into three types: igneous rocks, sedimentary rocks and metamorphic rocks. Now, what are igneous rocks? These rocks are formed through the cooling and solidification of magma or lava. About 65% of the earth crust by volume consists of igneous rocks. What are sedimentary rocks? Sediments are formed by weathering of earlier rocks by erosion in a source area and then transported to a place of deposition by water, wind, ice, mass movement of glaciers. These sediments get decomposed and form sedimentary rocks. Metamorphic rocks. These rocks are formed when sedimentary rock, igneous rock, are subjected to different temperature and pressure conditions than the pre-existing conditions. Now we will see different types of examples of rocks. Igneous rocks, granite, scoria, pumice, obsidian. Sedimentary rocks are sandstone, limestone, shale, conglomerate, gypsum. In metamorphic rocks we have marble, slate, quartzite and gneiss. Now, based on physical classifications, rocks are classified into stratified rocks, unstratified rocks, and foliated rocks. What are stratified rocks? These rocks have distinct layers along which the rocks can be split. Example: sandstone, limestone, shale, slate, etc. Unstratified rocks. These rocks do not have any stratification and cannot be easily split into thin layers. Example: granite, basalt, trap, etc. These rocks have crystalline and compact granular structure and cannot be easily split. Foliated rocks. These rocks have a tendency to split up only in a definite direction. Now we will deal with chemical classification of rocks. The rocks are classified as argillaceous, siliceous and calcareous rocks. Argillaceous rocks. The principal constituent is clay or alumina. The rocks are hard and brittle. Example: slate. Siliceous rocks. The principal constituent is silica, that is sand. The rocks are very hard and durable. Example: granite, basalt, trap, etc. Calcareous rocks. The principal constituent is lime. Example: limestone, marble, dolomite, etc. Now we will discuss properties of good building stones. The properties of good building stones are: appearance. The stone should be good in appearance. It should have fine, compact structure with definite edges. Structure. The stone should have uniform texture, free from cavities, cracks and patches of loose or soft material. The cracks and patches of the stone should not be seen by the naked eyes. Strength. Compressive strength of building stones in practice ranges between 60 to 200 Newton per mm square. Toughness index. For road works, it should be greater than 19. The stone between 13 and 19 is called as moderate tough and less than 13 is considered as poor toughness index. Hardness. For road works, hardness number should be greater than 17. Stone with hardness 14 to 17 are used for building works and less than 14 are considered to have poor hardness. Weight. It is an indication of porosity and density. More is the weight, more is the strength of the stone. Water absorption. It should not be more than 5% when a stone is put in water for 24 hours. Percentage wear. It should not be more than 2% for a good building stone. Seasoning. Like wood, the stones also need to be seasoned. The stone should be well seasoned. It is required in case of laterite stones. Specific gravity. The specific gravity of most of the stones lies between 2.4 to 2.8. Fire resistance. The stones should be fire resistant. Now we will study different types of tests performed on the stones. The different types of tests performed on the stones are crushing test of stone, water absorption test, abrasion test, impact test, and acid test. These tests are performed to find the suitability of stones for the work. Study about crushing test. To conduct this test, a specimen of size 40 mm into 40 mm into 40 mm are prepared, dressed, and placed in water for 3 days. The saturated specimen is provided with a 5 mm layer of plaster of Paris on its top and bottom surfaces to get even surface so that load applied is distributed uniformly. The specimen is loaded at the rate of 14 Newton per mm square per minute. The crushing load is noted. Then crushing strength is equal to the crushing load divided by the area over which the load is applied. At least 3 specimens should be tested and the average should be taken as the crushing strength. You can see in the image how the cube sample is made. It is of 40 mm into 40 mm into 40 mm and a 5 mm layer of plaster is applied on the top and bottom so that the load is distributed uniformly. Water absorption test. Cube specimen weighing 50 grams are prepared and test is carried out in the steps given below. Note the weight of the dry specimen as W1. Place the specimen in water for 24 hours. Take out the specimen, wipe out the surface with a piece of cloth and weigh the specimen. Let its weight be W2. Suspend the specimen freely in water and weigh it. Let its weight be W3. Place the specimen in boiling water for 5 hours. Then take it out, wipe the surface with cloth and weigh it. Let this weight be W4. Now water absorption percentage can be calculated by W2 minus W1 upon W1 into 100. The water absorption of a good stone should not be more than 5% when it is kept in water for 24 hours. Now we will deal with abrasion test. This test results indicate the suitability of stones against the grinding action under traffic. Any one of the following tests may be conducted to find out the suitability of aggregates: Los Angeles abrasion test, Deval abrasion test, Doris abrasion test. However, Los Angeles abrasion test is preferred since these test results are having good correlation with the performance of the payments. The machine is rotated for 500 revolutions at 30 to 33 rpm. Then Los Angeles value is found as weight of aggregate passing through 1.7 mm sieve upon original weight into 100. The sample is put in this machine and rotated for 500 rotations, and the sample is then again sieved with the help of 1.7 mm sieve. The sample passing to 1.7 mm sieve is taken and the Los Angeles value is calculated as the fineness value upon original value into 100. The following values are recommended for roadworks. For bituminous mix, the abrasion value equals to 30% and for base course equals to 50%. Now we will deal with impact test. Aggregates of size 10 mm to 12.5 mm are filled in cylinder in 3 equal layers, each layer being tamped 25 times. The same is then transferred to the mold and then again tamped 25 times. The hammer is then allowed to fall freely on the specimen 15 times. The specimen is then sieved through 2.36 mm sieve. Then impact value equals to W2 upon W1, where W2 equals to weight of fines, W1 equals to original weight. The recommended impact values for various works are: for wearing course, it should be less than 30%. For bituminous macadam, it should be less than 35%. For waterbound macadam, it should be less than 40%. Acid test. Acid test is used to check the weathering resistance of the stones. 100 gram of stone chips are kept in 5% solution of H2SO4 or HCl for 3 days. Then the chips are taken out and dried. The sharp and firm corners and edges are indication of sound stones. This test is used to test the cementing material of sandstone. Now let's study uses of stones. Stones are used for flooring and roofing. Stones are used in facework of buildings. Stones are used for paving of roads, footpaths. Stones are also used in the construction of walls, arches, bridges, columns, etc. Crushed stones are used as base course in the pavements. In the image, you can see how stones are used in the wall of the house. You might have also seen different uses of stones. Please comment and tell wherever you have seen the uses of stones. Know about some common stones which are used in the building. Granite. It has compressive strength 100 to 200 Newton per mm square. Its specific gravity is 2.6 to 2.7. Basalt. Compressive strength of 200 to 350 Newton per mm square and a specific gravity of 2.8 to 3. Gneiss. Compressive strength 50 to 200 and a specific gravity 2.5 to 3. Sandstone. It has compressive strength of 20 to 170 Newton per mm square and specific gravity is 1.8 to 2.7. Marble 70 to 75, specific gravity 2.65. Laterite, compressive strength 9 to 13 and specific gravity 1.85. Slate, compressive strength 100 to 200 and specific gravity 2.6 to 2.7. Friends, that's all for this video. Thanks for watching. Like and comment. Please subscribe my channel to get the latest notifications.